Okay, so here, this is solving some equations that we have to know. So for this guy, it says solve for x. It's already solved. I'm not going to go over one of these. Order of operations, you evaluate that number. You can do that on your own. Same here. It says solve for p. P is already solved for. You can evaluate that number on your own. Here's one where we want to solve for f. So we do have to do a little bit of work here. So remember, to solve, we're doing the inverse operation, or the opposite operation, to undo whatever's being done to the variable. So let me choose, oh, this is fine, I'll go with green. So first of all, if I look at f, if I plugged in a number, what's being done to f? It's being divided by 5, and then after that we would add 2. We're going to undo those in the reverse order. So if I would divide by 5 first and then add 2, we're going to do the opposite in reverse order. So we're going to subtract 2 off both sides. Okay, so we're doing the inverse of adding 2, which is subtracting 2. So I'm left with 2 minus 2 is 0, so I'm left with f over 5 plus 0 equals 8 minus 2 equals 6. You don't need to show the plus 0. I'm just showing you kind of what's happening here. So the plus 0, I need a smaller eraser than that. The plus 0, we don't need to show. I was just showing you to see what happens. So it's really f over 5. We say that those cancel. Okay? Well, I don't love that language. Anyway, actually, I should write my new equation in white to stay with the theme. So it's going to be f over 5 equals 6. Now from here, I want to undo the divided by 5. So I multiply both sides by 5. And I get f equals 30. All right, so you should be fairly comfortable with that. And so on D, you have to solve for t. I'll leave you to that. E, you have to solve for y, and that's got some scientific notation in it. So you can think of these as just, this is a number, and this is a number, right? So don't get freaked out by the scientific notation. So we're solving for y. So what's being done to y? It's being multiplied by that number out front and then divided by the number underneath it. So first, I'd like to get rid of the division. So I'm going to multiply. I'm going to do the opposite, or the inverse, on both sides of that division. I'm going to multiply both sides by 1.5 times 10 to the 15th. All right, I'm going to multiply this number times this number over here. I don't have room to squeeze it in there, so I just wrote it like that. So then these will cancel out, or what happens there is when you divide them, they equal 1, and then 1 times the remaining stuff is just this stuff. So 3.0 times 10 to the 20th times y. Over here, to do our multiplication, we got 4 times 1.5, so that's 6. And then we add our exponents, 10 to the 20th. Now, to solve for y here, I want to write my equations in y and my inverse operations in my equations in white and my inverse operations in green. So my new equation there, after I multiplied both sides by that, would have been 10 to the 20th times y equals, that was what, 6 times 10 to the 20th. Okay, now I'm going to divide both sides by the number that I'm multiplying y by. So these guys here equal 1, because when I divide them I get 1, and then 1 times y is just y. And then 6 divided by 3, I divide, remember doing scientific notation, or these type of numbers, they're not always in scientific notation, these happen to be. 6 divided by 3 is 2. Then I can do the tens, and since I'm dividing tens, I subtract. So then I get 10 to the 0, so y equals 2, because 10 to the 0 is just 1. Okay? All right, now this next set of problems, this would be called solving literal equations, where there's a lot more variables in there, and we identify one of those variables we want to solve for. So we want to solve for r. So I think of r as the variable here, and all the other ones now, I can treat them as numbers. Like maybe this was a 5, and maybe that was a 3. So if you think of it like that, I had 5 equals 3r. I would just rearrange those if it was a 3, right? So if you think of it like that, solving for r is not hard at all. So those other ones, you just treat them like they're constants or numbers. So if I'm solving for r, I like to box the variable. I'm going to divide both sides by z, and I get r equals d over z. I know I didn't write it in white, but that one was simple enough. That's called solving a literal equation. Okay. Let's go down and do another one here. So let's look at this guy. They want us to solve for t sub 1. So that's my variable. This one's interesting because whenever the variable's in the denominator, you got to get it into the numerator. When I have two fractions equal to each other, I like to just cross multiply them. So, another way to look at it is you multiply both sides by t sub 1 and then multiply both sides by t sub 2. So I'm going to start by multiplying both sides. I'm just going to do the cross multiply. I'm going to do both of those things in one step. So my new equation is going to be t sub 1 times p sub 2 v sub 2. And the other side of my equation is going to be t sub 2 times p sub 1 times v sub 1. And remember, we're solving for t sub 1. So now I have t sub 1 times all these different variables here, a p and a v, right? So I'm going to divide both sides by p sub 2 v sub 2 on both sides. So over here, over on this side, those equal 1. You divide those equal 1. And 1 times t sub 1 is just t sub 1. And on the other side, I have t sub 2 times p sub 1 v sub 1 over p sub 2 v sub 2. And you can't cross off the p's. You can't cancel the p's. You can't say p sub 1 divided by p sub 2 are the same thing and they equal 1 because they could be different values of p. So that's solving literal equations. I did a couple there with you. You're going to do the ones that I didn't do and then also complete the extra practice I gave you.